I etched my first circuit board. It's not perfect, but it will work. The things that are wrong with it, I can fix it. If I had to do it all over again, what I would do was, the kit said to leave it develop. I used the photo method. The kit said leave it develop for 8 minutes. I left it develop for 9.5. I should have left it for the 8 minutes. I also should have doubled up on the transparencies. I went and I printed a high quality copy of the circuit, and then I walked to FedEx Kinko's and had it transparency copied. It only cost 80 cents for a transparency. I should have doubled it up. So I should have doubled it up, and I should have not let it expose for as long. But like I said, it will work. Now I just had to drill all these holes out. So that's my first time etching, and for some reason I was always a little afraid to etch a circuit board, but I'm glad I did it. So now I just have to drill all the holes. This thing kicks butt. You know, there's bad reviews on it saying that it's not accurate, it's cheap. It's the Dremel drill press. But it's the best thing I ever bought, man. I knocked this whole board out within an hour. Knocked all these holes, as you saw before. And I didn't break one bit. That's a 1/32 inch bit. Drilled all these with one bit. So, yeah, even though a lot of people say it's cheap, doesn't work accurately, I disagree. I have nothing but good things to say about it. So now we can start soldering and start putting the board together. Okay, so I went and I soldered on all the jumpers above it and these two sockets. I'm already noticing that some of these traces are incomplete and have to be filled in with solder. And I'm also missing a couple things that I didn't realize I was missing, like dip sockets and such. So the way I'm going to attack this is I'm going to get all the components soldered up that's needed to run the main chip and the EEPROM and the LED array down here at the bottom. That way I can work on the software side of things, because I have yet to, when I was waiting for the board to get drilled, I figured out how to use I2C and work with external EEPROM, but I have yet to implement that in the software. So I'm just going to get everything set up for the main chip and the EEPROM, everything I need. That's what I'm going to work on now. Okay, so I soldered everything I needed for the main chip. I put a brand new main chip in, 18 Mega 644, straight from the packaging, and I just went and successfully burnt the fuses using the ISP. So this is all set up, this works, power light is on. Yeah, cool. So now I can begin just messing around with this, you know, with it. If you look on the back here, as you can see, I filled in some traces that were messed up. The weirdest part is this trace right here was messed up, but I couldn't, it looked perfectly good. Unless you had an ohm meter to it, you wouldn't realize it was messed up. But I filled it in, and we'll see if anything else is messed up as I go along. But so far, pretty happy about it. Okay, man, this thing gave me hell, but I got the main chip up and running. Let's see, let me go through things that gave me trouble. Its main chip up and running is programmed, and it's using its internal EEPROM for storage. It's not using the external EEPROM yet. I might just keep it that way till I get everything back together. First things, the transistor on the trigger circuit, it needs to be installed backwards. I must have done that by accident and it seems to work. But when it's installed the correct orientation, it doesn't work. When it's installed backwards, it's working. I had a trace. This trace right here was blown out, and I didn't realize it until I put a voltage meter over it, and it was completely open. I had to put a voltage meter over it to realize it's open, not an ohm meter. And then finally, the biggest problem was in the test program of the software. During the interrupt, I was outputting to the LCD screen, which means it was having a delay of around 10 milliseconds. When I took out the LCD software, that 10 millisecond delay was taken out of the interrupt sequence. And that makes a big difference. That 10 millisecond delay, I guess, acts as the bounce for the trigger circuit so it doesn't go crazy. So I put in a 10 millisecond delay in place of the LCD code, and now it works fine. So it's every 10 times a second, 10 hertz, which is 100 milliseconds. It's getting a trigger from the iPod to move on to the next data frame. And these are all the data bits. They're not programmed yet. This one flashing here is flashing every second to make sure that, you know, it's incrementing. And then this last one here is 0. Okay, it was end of the show. So it zeroed out, and then the show looped back again. So that's what I got done so far.